Hello friends, welcome to lecture number 18 of electricity and magnetism. Today we are going to discuss about uniqueness theorem. And before we start, please subscribe the channel if you are new to my channel. Also share with your friends, hit the thumbs up button, also hit the bell icon so that you get notified when new video will be uploaded. And I have provided the previous lectures, a link of the previous lectures in the description box. If you haven't watched those, then you may go through if you want. So now let's start. So now you see, before we discuss about uniqueness theorem, here you see, we have already got Laplace equation, right? Laplace equation, that is, according to that, suppose we have closed region enclosing no charge. Here charge is suppose 0, volume charge density is 0. In that case, Laplace equation, that b square, not b square, del square of b is equal to 0. This equation is valid in this region, right? So it is such a region that if you take a point here and if you have a charge outside this region, right, outside this region, then now you see, if you draw a sphere, if you imagine a sphere around it, keeping this point at center, then potential due to this charge at each and every point, right, of this sphere, if you find the average of the potentials at each point, at all the points on this surface of this sphere around this point, that average of those potentials will be equal to the potential at this point due to this q charge, right? Okay, it's such a region. So now you see, that means the potential within this region cannot be maximum or minimum. That means throughout the whole region potential should be same, right? Because here you see, suppose at this point potential is maximum. If it is maximum, then it cannot be equal to the average of the potentials at all the points on the surface around this point. Okay, is that clear? So hope this thing is clear. So now you see, let us take a situation. Now you see, the potential at the surface, at the boundary, suppose it is specified that that value is fixed, that is given. Suppose that electric potential at the boundary is, suppose, let me take Vd, this value is specified, and here Laplace equation is also valid. Then this Laplace equation, in this Laplace equation, so that means the potential, this del v square here, it is del v square is equal to 0. Here v satisfies this Laplace equation, and when it comes to boundary, it has a specified value, that is Vb, right? So let me consider that way. Then according to the uniqueness theorem, now you see, let me write the uniqueness theorem. So this is the uniqueness theorem. Uniqueness theorem. So this is the Laplace equation in a region which is valid in a region that should be region not enclosing any charge. The value of the electric potential V. So I forgot to mention this here. Let me adjust a little bit. So value of electric potential V is the electric potential here. This is specified at all the points at the boundary. Okay, so at all the points the value of this electric potential is specified. Then within the region this V is unique. That means we can say this Laplace equation is equal to 0. This is what Laplace equation has unique solution. Right. So now let us prove this. Now let us consider this region. not enclosing any charge, where this Laplace equation is valid. Now let us suppose this Laplace equation del square v is equal to 0 has two solutions. Suppose let us suppose that this equation has two solutions within the region and those two solutions be v1 and v2 such that they have different values within the region. We have assumed that way, satisfying this equation, and at the boundary they have the same specified value, because this electric potential is specified at this boundary, okay, such that v1 is equal to v2 at the boundary. So at the boundary we have considered this, right? So now you see, we have considered this that this v1 and v2 are different solutions satisfying this Laplace equation and have the same value at the boundary. So here we also can write that del square v1, because they are the solutions of Laplace equation, is equal to 0, and del square v2 is equal to 0, right? We can consider that way. Now you see, let us consider that within this region the potential difference between these two. Now let us consider v3 such that v1 minus v2, which is the difference between v1 and v2, okay? So now taking the Laplacian operator on both sides, we're gonna get this. So here you see, this must be equal to 0, because here we have got this pair, from this pair of equations. Let me take equation number 1. From 1 we have got del square v1 is 0, del square v2 is also 0, so 0 minus 0 from 1, so that's gonna be 0, right? Which means v3 satisfies the Laplace equation. This is Laplace equation, right? So let me go to the new slide. So let me write the equation again. So what we have got in the last slide, that is the del square v3 is equal to 0. That is the Laplace equation. And since v1 is equal to v2 at the boundary, right? So v3 will be equal to v1 minus v2, as v1 is equal to v2 at the boundary, so the difference will be 0, right? And also here you see, this equation is Laplace equation. This is Laplace equation. So now you see, it is observed that v3 satisfies that Laplace equation, and it is 0 at boundary, and satisfies Laplace equation, right? So which means that it doesn't allow any maximum or minimum within the region that we have taken here, within the region, and so it if it doesn't allow any maximum or minimum within the region, and it satisfies here you see Laplace equation, it is 0 at boundary, so it must be 0 within the region as well also. So that is why again v3 is equal to v1 minus v2, so that should be also equal to 0 within the region. So these two are equal, v1 is equal to v2, so which means this Laplace equation must have one solution, that is unique solution, right? So that's how we can prove the uniqueness theorem. So hope you have understood this. So thank you for watching. please subscribe the channel if you are new to my channel, and share with your friends. Help me to grow my channel, inspire me to create new contents for you. And thank you for watching. See you in the next video.